Okay, so we still have actually a little bit left in section 13.1. This is an example that I always show the students coming from 13.1. So the following example shows the importance of starting early to maximize the long-term advantage of compounding. Compare the results of two people saving for retirement at age 65. Both plans earn 8% annual interest throughout the billing period. Okay, so we got Plan A and Plan B. And you can see that, they both show different amounts here. Okay. So Plan A is Heidi, we'll call this person. And she begins saving at age 20 and deposits $2,000 on every birthday from age 21 to age 30. Okay. So that's 10 deposits total, or $20,000 total. Okay. After age 30, she doesn't make any more contributions to the account. Okay. She just lets the account do its thing. Plan B is Tom. Okay. Now Tom waits until age 30 to start saving, and he makes deposits of $2,000 on every birthday from age 31 to age 65. So that's 35 deposits, or $70,000 total. Okay, so you can see that he doesn't make any deposits until age 30, and then from age 30 to age 65, he's gonna make he puts in $2,000 each time. Okay. The table shows how both accounts build over the years, but the $20,000 deposited earlier produced about $83,744 more than the $70,000 deposited later. Why did that happen? I mean, Tom deposited so much more money in the account. Wouldn't you expect Tom's total amount to be bigger? Okay. Than Heidi's. So why did this happen? The earlier deposits of Plan A outperformed the greater deposits of Plan B because the interest rate was high enough. That Plan A at age 30, Plan B could never overtake it. Okay. Despite an additional Plan B deposits from then on. Okay. The rate of return is important. Okay, if the interest rate had been 6% rather than 8%, Plan B would have overtaken Plan A. That would have happened, but it wouldn't have happened until age 57. Okay, so at age 65, you would have come out, let's see, Plan B would have overtaken Plan A, and at age 65, it would have come out ahead by $20,253. So the basically what this problem is it's a problem about life, okay, and investing money, and just the importance of investing money. I mean, because some people are going to wait till later to invest money, and in the long run, that will hurt you. Okay, if you don't invest anything until later, or not even at all. I mean, that you can see just the amount of money that there really could have been. Okay, so now the interest rate is important. Okay, the 8% is important. Okay, so at 6%, Plan B would have overtaken Plan A, but it wouldn't have happened until age 57. This example is in all math books. It seems all math books about money, and it seems like they try to emphasize the importance of investing early, just because it's a very important thing that not many people do. Okay, but it has a real advantage, though. You can see. Okay, so that was part of section 13.1 there, and so actually here's where section 13.2 begins. In 13.2, we're going to talk about two types of credit, which is called open-end credit and closed-end credit. Borrowing money to finance purchases and repaying the money back with periodic payments is called installment buying. We're going to discuss two types of consumer installment credit. The first type is called closed-end credit, and that's where money is paid off in a series of equal payments. So, for example, furniture, appliances, cars, those are commonly financed through closed-end credit. Okay, and then there's open-end credit as the second type of consumer credit, and that has no fixed number of payments. Okay, the customer just continues to pay until no balance is owed. There's a minimum payment, okay, that has to be paid, and anything above the minimum would be ideal. Okay, but common examples of open-end credit include most department store charge accounts on credit cards. Okay, a credit card is like the example of an open-end credit situation. So how I have this section set up is that we'll first look at some closed-end credit problems, and then we'll look at some open-end credit problems probably in the next video. Okay, so problem 9 says that the monthly payment required to pay off an auto loan of $9,780 over 3 years if the add-on interest rate is at 4.3%. Okay, we're going to find that monthly payment. Okay, the first thing that we need to do is we need to find the total amount that we'll be repaying. That's important, okay? And that is, we got to find A, and we're going to assume simple interest, so nothing's being said about compounding or anything like that. So I'm going to use the formula for simple interest. You take $9,780 times 1 plus the rate is at 4.3%, so 0.043 is the decimal form. It's going to take 3 years to pay this loan back. Okay, 1.129. And by the way, something I guess I really should have mentioned in the last video is the fact about rounding. So I would personally show all the digits that display on the calculator. Okay, some people are going to call this 1.1. Okay, and then they'll be off by pennies, or in some cases hundreds of dollars, depending on the principal amount. Okay, but so the rounding obviously has a huge part in what your answer will be, and I like your answers to be to the nearest penny. Okay, if you're a penny off, I mean it marks it wrong. Okay, so what I would recommend is to show all the digits that are on the calculator. Okay, the further out you go, the better. Okay, so if I were to take 9,780 times 1.129, I get $11,041.62. Okay. So what is the monthly payment going to look like? Well, there's 36 months in 3 years, so I would divide this amount by 36, and $306.71 per month is what I'll be paying then. Okay. By the way, you see the amount of money that we're going to be repaying back, even though we borrowed $9,780 for this auto loan, that's not the amount that we're paying back. Okay, it's actually this amount. It's $11,041.62. So anytime that you can buy an item with cash, that is ideal. Okay, some people take out a loan for everything, and that comes back and bites them later, because they have all this interest to pay. Okay, so in some cases, it could be high interest rates. Okay, so you got to watch out for that. Paying with cash in any case is the best option. A young couple, problem 10, a young couple bought $4,300 worth of kitchen appliances and made a down payment of $1,000. The balance was financed for 12 months at an add-on interest of 8%. Find the monthly payment. Okay, so the first thing that I'd like to do is find the total amount that we're going to be repaying back, because it's not going to be the $33,000 $3,300. Okay, there's interest involved. Now, the couple wisely put down a down payment of $1,000, so they're going to be owing back, $3,300 plus the interest. Okay, let's see how much there's going to be in interest here. So I got the $3,300 times 1 plus 0.08 is the interest rate times 12 months, that's 1 year. And so 1.08 times 3,300 gives me $3,564. Okay, so $264 extra is what they're going to be paying back. I guess one of the things that you want to consider is it worth it to repay all this interest back? And in some cases, if the interest rate is very high, no, it's not going to be. In some cases, not going to be much. Okay, it just all depends. So if I take the amount divided by 12, then there's going to be $297 per month is what I'd be paying in order to get this balance down to $0. Okay. Problem 11, you are making payments of $207.31 to pay off a 3.5-year loan worth $6,400. What is the add-on interest rate to the nearest tenth of a percent? Okay, so 3.5 years is 12 months in a year. If I take 3.5 times 12, I get 42 payments that I'm going to make. And it's going to be the same amount every time. Okay, this is a closed-end credit problem. Okay, these problems 9 through 12 are all examples of closed-end credit problems. Okay, so the amount that you're paying is going to be the same amount per month. Okay. The amount that we're going to owe, so we're paying $207.31 over a 42-month time span, so that's going to be $8,707.02 if you multiply those two numbers. Okay, that's going to be the future value. Okay, so you can compare that to what the loan is, and it looks like we're going to be paying back $2,307.02. That's quite a chunk of change. Okay, the amount is equal to the principal times the quantity 1 plus the rate times the time. The principal amount is the $6,400 times 1 plus the rate. I don't know the rate. I'm supposed to find the rate times the time. So 3.5 years is the plan. And if I distribute 6,400 into these two terms, I get 6,400 plus 6,400 times 3.5 is 22,400, okay, times R. Okay, and if I subtract 6,400 from $8,707.02, then I get $2,307.02. Okay, divided by 22,400, and so R, if you round to the nearest 3 places, R is 0.103. Okay, now the reason why I'm going to the nearest 3 places is because I need to go to the nearest tenth of a percent. Okay, so that'd be the nearest 1 digit when converted to a percentage. So 10.3% rate, that'd be the interest rate. That's a lousy rate, by the way. Okay. Problem 12. How many payments must you make on a $10,000 loan if you pay $417.92 a month and the add-on interest rate is at 10.15%? Okay, so how many payments must you make? Okay, well, so I I have the future value divided by the number of payments. There's 12 months in a year, so 12T would be the number of payments that I'm going to be making. Now, I'm told the amount that I'm paying per month, that's $417.92. Okay, so that would be equal to $417.92. Okay, A is given by P times the quantity 1 plus RT. Okay, again, nothing's being said about compounding here at all in any of these problems, so I wouldn't read into it. Okay, the present value is the $10,000 times the quantity 1 plus the rate is at 10.15%, so as a decimal, that'd be 0.1015 and then times t. Okay, if I distribute the 10,000 into these two terms, I get 10,000 plus 1,015 times t. Okay, so that's going to be the future value, or that's going to be the numerator, divided by 12t gives me my, my monthly payment. Okay, if I multiply both sides by 12t, so 417.92 times 12t gives me 5,015.04t. If you subtract 1,015t, then we're looking at 4,000.04t equals 10,000 divided by 4,000.04. So t is roughly 2.5 years. Okay, now they want to know the monthly payments. Okay, so how many payments must you make? Well, in 2.5 years, there's 12 months in a year. So 12, 24, 30 monthly payments. Okay. Now, these are some examples of closed-end credit problems. In the next video, we'll look at some examples of open-end credit problems. I mean, the common example is a credit card. Yeah, we'll go ahead and stop right there.